Determine the magnitude, direction, and position of the resultant force system with reference to point A for the non-coplanar force system shown in figure. Now, first resolving this force into horizontally and vertically. Horizontal resolution is 100 root 2 cos 45. Vertical resolution is 100 root 2 sin 45 degrees. Now, resolving forces horizontally and vertically, summation fx and summation fy. Horizontal components are 100 root 2 cos 45, 100 root 2 cos 45 directed to positive x-axis, and 100 Newton directed to positive x-axis, so plus, and 100 Newton directed to negative x-axis, so 100 Newton negative directed to negative x-axis. So summation fx equal to, now resolving this force into 100 root vertical resolution, it is 100 root 2 sin 45 degrees directed to negative y-axis. So now resolving this force into 200 vertically, it is 200 Newton, it is directed to positive y-axis, so plus 200 Newton plus directed to positive y-axis. Now summation, calculating all this we get summation fx value, calculating all this we get summation fy value. Now resultant is given by square root of summation fx square plus summation fy square. Substituting for summation fx value and summation fy value, we get r value, and resultant direction is given by theta equal to tan inverse of summation fy by summation fx. So theta equal to 45 degrees. So what we have, summation fx value, summation fy value, summation fx and summation fy value both are positive, so the resultant value and theta value, so resultant is located in the first quadrant making 45 degrees to the horizontal. We know resultant is in first quadrant, but to locate its exact location we have to take moment about point A. So now taking moment of forces about point A, first consider these two components. Now first this component, it will have line of action like this, and it will pass through line of action like this, and it is passing through point A. So its perpendicular distance about point A is 0. So moment of this component is 0 about point A. Now consider this force. Its line of action is like this. It will move along line of action like this, and its perpendicular distance will be this one, and it will rotate about point A like this. So it will have perpendicular distance of 4 meter, and 100 Newton into 4 will be its moment, and it is rotating clockwise. So 100 into 4, it will rotate clockwise. So now consider this 100 Newton force. Its line of action is like this, and it is passing through point A. So its moment about point A is 0, as it is having 0 perpendicular distance about point A. So its moment about point A will be 0. Now consider this component 100 root 2 sin 45 degrees. Its line of action is like this. So it will pass through plane of action, and it will have perpendicular distance of 4 meters about point A. So it will rotate like this clockwise. So 100 root 2 sin 45 into 4, rotating about point A clockwise. So plus. Now consider this 200 Newton. It will have line of action of force like this, and it will pass through line of action of force, and it will have perpendicular distance of 202 meters, and it will rotate about point A like this, anti-clockwise. So 200 into 2 meters rotating about point A anti-clockwise, so minus. So what we have calculated is this much. What we will get summation MA value, and D, that is perpendicular distance of resultant from point A, is given by summation MA by R. Substituting summation MA value and R value, we get D value, and x-intercept we get by summation MA by summation Fy. Substituting those values, we get x-intercept, and y-intercept is given by summation Mi by summation Fx, we get y-intercept. Now, so we have summation Fx, summation Fy, R, theta, D, perpendicular distance about point A, and x-intercept and y-intercept. So what we have is x-intercept 4 meters, y-intercept 4 meters, and D value, that is D value 0.358 meters perpendicular distance.